Hi, my name is Pat Schaff and welcome to Making the Space. Today we're going to go over a CNC machine that is at TxRxLabs. One of my neighbors and I took the class. I took it years ago and then we both took it a few months ago. And we both kind of forgot how to use the machine. So Mark, this video is for you. Hopefully this helps both of us remember how to do this in the next 6 months. Our eventual goal is to be able to build a CNC cut piece of furniture or something like this. This stool, for example, is something that was done on the CNC machine using 3/4 inch plywood. The idea is you cut a flat layout and then assemble it, and all the design starts in Fusion 360. With Fusion 360, we're going to create a simple circle, put a couple eyes and a mouth on it, and then lay it out to be cut on the CNC machine. To start with, you create a component. From the component, then you can put a sketch on top of it. I'm going to call the initial component Simple Example, and then we can put a circle in either by creating the circle or doing the pull down and saying the type of circle we're going to do. All the tutorials and design classes I've taken with Fusion 360 say to start at the center axis and expand from there. Doesn't necessarily work with the CNC machine, and we'll kind of get into that later. But basically, if I start in the center and expand everything around the center, when I go lay out the CNC machine, I need to position the bit in the center of the design, not on the edges of the design. So my preference would be to have the bottom left-hand corner be the edge of the design, not the center, but for this example, we'll do the center. So just to mix things up a little bit, let's use pentagons for the eyes. We'll go to create and then go to pentagon and do inscribe pentagon and create a 1/2 inch circle that will inscribe a pentagon on the inside. Notice as you move the mouse around, the points move as well. So it's important to line it up appropriately so that you get the right size and the right orientation. So we could draw a second pentagon just by repeating the same step as before, or we can highlight the existing one, right-click and go to Move/Copy, scroll down, select Copy, and then translate it over to a respectable distance so that it's symmetrical across the center. After we create the second one, we'd like to move the original one just a tiny bit over. Notice if we highlight it, grab it, and move it, it's locked to the grid lines. We have to zoom in to get a much finer resolution so that we can move it just a tiny bit as opposed to large increments. This is true throughout Fusion 360 in that the resolution of the grid locks you to the steps. So zooming in gives you much finer resolution and movement. The last element we want to create is the mouth of the face. So to do that, we select a spline. And the only restriction is it needs to be not too tight of a radius because we're using a 3/4 bit on the CNC, and it has to be a closed object. So we draw the line, we make sure we put some profile to it, make sure it circles back and connect back to the starting point. So at this point, we're done with our design. What we need to do is finish our sketch and then go in and create a custom parameter because we'd like to have a variable depth of the material. You really don't know how thick material is. It might be 3/4 inch, it might be 5/8 inch, might be 1/2 inch. So if you go into modify custom attributes and define a board thickness as 3/4 inch, we can change it later. So following the example that Joyce used for teaching the class on the CNC machine, we select the eyes and the mouth and then extrude it to half the depth of the board thickness. And then for the rest of the face, we extrude it to the full board depth so that we get a piece that we can cut out on the inside and cut out on the outside at two different depths to show two styles of cutting on the CNC. At this point, we're done recreating what was done in the class as far as design. We've got a face. We'd like to save it. Typically, you save between the design and the manufacturing so that you can go back and update things as needed. If we were taking this to the laser cutter or to the 3D printer, we would export it as a DXF file. Since we are using the CNC machine, we actually need to go in and define a manufacturing process. And that's done where it says design, you select manufacture, and can go in and define how you want this cut on a CNC. The first thing that needs to be done in manufacturing is to define a new setup. And this basically says here is the body that we are cutting, and don't really need to select a tool or anything special. That's done on the cut specific. So there are two basic cuts that we're going to do. One is the pocket, and that will do the eyes and the mouth, and the other is the contour, which we'll do around. We start by doing the pocket. One thing you do have to know ahead of time is the type of bit you're using. Is it a 1/4 inch? Is it an 1/8 inch? Is it round nose? Is it flat nose? Whether it's an upcut or downcut, that doesn't matter. But you do need to go in and select. I usually go in and select all, and then type in a search function, and that pulls in all of the 1/4 inch or all of the 1/8 inch and allows me to define exactly how to cut. The default parameters that come with the Fusion 360 are a little off. We need to go tweak the spindle speed to 18,000 RPM and then change the feed rate to 60 with the exception of the plunge rate. We'd like to change it to 40. These are typical values. You might want to play with them a little bit to see what works for you, but this is what was recommended in the class. The next step is to select the contours that we want to cut. We do that by selecting the second tab in the pocket definition and then selecting the eyes and the mouth. Now notice the arrows. The arrows go two different directions, and the blue highlights whether we're going to cut outside of this or inside of this. And we can click on the arrow, make it go the opposite direction until we get the blue inside of all three of the elements that we're trying to cut. Given that these are pockets that we're cutting out, we want to select the depth of the cut and make sure we're cutting from the top of the material to the bottom of the contour, not the bottom of the material. So make sure the bottom height is set to selected contour and it will work perfectly. So the final step for cutting our pockets is to define the multiple depths, and that is the fourth tab over. We select it and then go down to multiple depths. We enter the depth that we'd like to cut is basically the width of the bit. So for ours, we're using a 1/4 inch bit. We'd like to cut a 1/4 inch down, and that way it doesn't dig too much in and put too much torque on the bit. To verify that everything worked, we can go to the action simulate and look at the simulation of the cutting. Now, had we gotten the arrows in the wrong direction, we would be cutting outside of the pockets as opposed to inside the pockets. And it's much easier to figure that out and troubleshoot, diagnose it in simulation rather than on the actual wood. The final component to cut out our face is to select the contour, which is the circle around the face. And to do that, we go to 2D contour and select the same tool because we don't want to change tools, and then select the circle around the face. The arrow, doesn't matter which direction it is, up or down will work perfectly for this since we're not doing a pocket cut. Given that this is going to be a cut all the way through, since we're cutting the face out, we want to put tabs in. So we select tabs, we define how wide we want the tabs, typically a 1/4 inch is good enough, how many tabs we want around the circle, and a 3-inch spacing is pretty good. And then the final step is to define how deep we're going to cut, and that would be the bottom height should be the stock bottom as opposed to the contour bottom, and that ensures we cut all the way through. It's easiest to see this when you switch to the perspective view as opposed to the top view because it gives you a relative depth of how deep things are going to be cut. Along with selecting the contour bottom, we want to go in and select multiple depths so that when it cuts, it doesn't cut 3/4 inch with a 1/4 inch bit. We'd like to say don't cut any deeper than a 1/4 inch because it would torque the bit too much. So the concept here is we select 1/4 inch for the depth and then click OK, and we are done defining our contour. We can again simulate, see how the cut goes, and notice that it does 3 passes. Since this is 3/4 inch thick and it's doing a 1/4 inch each time, we can see the passes do exactly what's expected. So the last and final step in generating our CNC cut list is to go to Actions and do post-processing. Now, in this video, there's a slight problem in that we're only doing the outside face, and I've made this mistake multiple times. You have to select all of the cuts, not just the one you did last, because when you save it, it saves it as cutting what you highlighted. So in this example, we're going to have a bad cut, and we'll have to go back and redo the definition. Since we have to regenerate the cut list with both the pocket and the contour cuts, let's change up the design a little bit and then redo it. So the first step is to go in and select the parameters and say we've got a 1/2 inch piece of wood instead of a 3/4 inch piece of wood, and see how that affects the pocket cuts as well as the contour cuts. So going back to the manufacturing, we highlight the setup one that we've initially defined when we first started this process, right-click and hit regenerate. It goes through and regenerates all of the cut lists, the cut depths, and everything that needs to be cut for everything. We can go into the action simulate and verify that the cut happens the way we should. Now notice we're selecting the setup, so it's going to show us both the pocket and the contour cuts, whereas previously we had one selected. Now it's going to show us the entire cut. So it's important to note that we have both of the cuts selected here, the contour and the pocket, so that when we save the NGC file by doing the post-processing, it will generate the cuts for everything in this diagram. Once we have it saved to the disk, we can verify it by going to the file system and looking at it. We then copy it to a thumb drive and time to go into the woodshop. So for this example, I'm using a scrap piece of 3/4 inch plywood that I found in the spare wood bin over by the table saw, and we screw it down. We get some Phillips screws, which are on top of the computer in a box, and screw down the piece that we're looking to cut. We want to make sure it's firmly fastened to the wasteboard, because the CNC machine has enough power to fling this piece across the room, and we want to prevent that from happening. So the power switch, which is underneath the computer, the far right one, powers on the CNC machine. This allows us to go in and follow the checklist, which is typically magnetically attached to the right side of the cabinet. The first step is to launch the Linux CNC program that should be on the desktop. It randomly gets moved, so look for the penguin, launch that, and it will allow you to go in and begin the checklist. With the power button turned on and the Linux CNC program running, the first step is to go in and click the power button inside of Linux CNC. This basically energizes all the components, everything's ready to go, and initially you have to home everything, so you click on the Home All button. This will make the machine recalibrate the XYZ axis, put everything in the top left corner away from the computer towards the front of the building so that it's ready to be calibrated. One of the next steps is to go in with the MIDI command line and tell the Linux CNC that it's using a certain tool number, and the tool is specific to the tool number you selected in Fusion 360. Typically tool 1 is what's used, so you go and execute the M6T1 command. So to get the bit mounted on the CNC machine, there's a chuck that's available on the left-hand side of the computer mounted in some brackets. On the right-hand side of the computer, on the workbench next to it, is the tool to lock the bit into the chuck. Now, the recommendation is all of the shaft should be as far down into the chuck as possible so that the bottom of the bit showing is the last little bit of the cutting edge with very little shaft exposed. The green button on the left-hand side of the CNC machine to the left of the motor is a vacuum engagement or release button. This allows you to take the chuck, holding it by the bit, not by the sides, to insert it into the hole, press the green button, and it will vacuum suck the chuck into position, and everything's ready to cut. The final machine preparation can be seen on the back of the checklist or the second page of the checklist, and that is to set the X, Y, and Z reference point. To do that, you use the left and right and up and down to move the X and Y axis, and then page up and page down to move the Z axis. The greater than, less than allows you to speed up or slow down the way things are done. Prior to doing the XY calibration, I typically load in my design file. In this example, we had the bogus where we just cut the outside circle as opposed to the whole face. And that allows me to move it over and center the bit over it by recalibrating the X and Y coordinates. It's kind of silly to coordinate all the motion with no design, so I typically load in my design before I calibrate. For the X calibration, the left and right arrow keys move the gantry accordingly, and for the Y axis, the up-down arrow keys move it accordingly. The greater than, less than will speed up the traversal of the head motion. It might be moving really, really slow at first, and if you use the greater than sign, it makes it move faster. For the Z-axis, I typically move the keyboard over closer to where the bit is so I can move it up and down. You have to be real finicky and play with it. What you'd like to have is the tip of the bit touch with the paper width distance above your design. Otherwise, you're either not going to cut deep enough into your board or cut too deep and cut into the wasteboard. It's important to note that you have to select the X-axis and touch off, select the Y-axis and touch off, select the Z-axis and touch off. Now, once I've touched off all three, I can move the gantry, I can raise the head, I can do whatever I want, because when I say execute, it's going to position to the right location and do what it needs to. Prior to executing the code, we need to ramp down the speed so that the gantry doesn't move and we can slowly make it go the way we want to. We do this by bringing the speeds down to 0 and then get everything ready to begin cutting. Once we click play, nothing's going to happen because we have set the feed rate and the rapid rate to 0. We can go verify everything's set up, make sure everything's the way it's supposed to, and then slide the rapid rate, the gantry should start to move, slide the feed rate, and it should start to cut. Once we slide the rapid rate and the feed rate up to 100 each, we should start seeing dust. The cutter should start cutting into the material. This example, we're cutting an MDF board just as a scrap that was found in the tool bin, so that we make sure we're the right size, we're the right depth, we're not cutting too far into the wasteboard, that everything's set up appropriately before going with our expensive piece of wood. So the steps are exactly the same for more complex pieces, just you've got more pockets and more contours to find. In the example we started with, we're going to do a stool, and the stool has 2 legs and a top. We go in and bring that design into Fusion 360, go into the manufacturing, go into the setup, and make sure we've got everything defined so that we can verify it. Now, if I want to cut just the top and 1 leg, I have to make sure I go in and select the proper pocket and the proper contours that I'm trying to cut. So in this example, I would not select the 3rd pocket, not select the 1st contour, which would be the leg on the bottom left. but I'd select the other ones, and that would generate a cut list for just those two components. The easiest way to select everything is to go in and click on Setup and then go to Actions Post-Processing, and that will generate the cut list for all three pieces. Now, I can go look at the times that are estimated on each of the pieces if I go in and look at that, and that gives me, is it going to take 5 minutes, is it going to take 50 minutes? So Mark and the rest of you who took Joyce's CNC class, which is a 3-day adventure, hopefully this is a good 20-minute tutorial and refresher to tell you everything you forgot in those 3 days. So I know I lost all of my memory 3 years later when I came back to do the CNC machine. Things had changed. I wanted to make sure I still understood it. And with the help of the staff at TxRx, I was able to cut a few things and am proficient with the CNC machine again.
Now back to your regularly scheduled program.
And while some may see them as the crazy ones, we see genius. Because the people who are crazy enough to think they can change the world are the ones who do.